In this video, we're going to talk about two more of our postulates, the ruler postulate and the segment addition postulate. The ruler postulate says every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. That just means for each point on the line, it goes to one and only one real number. The real number that corresponds to a point is called the coordinate of the point. So that sounds nice and fancy, but really it's pretty simple. I do want you to write all this down, so I'll give you some time to do so. What this allows us to do is to measure the lengths of segments using a given unit, in this case if you look at our ruler, inches, and to find distances between points on a number line. So you have to know your unit, and then you can find your distance. Now the way we define distance, it looks complicated, but it's pretty simple. The way we define distance, the distance from A to B, is written as AB, notice there's no line over top, and is the absolute value of the difference of their coordinates. So AB is equal to the absolute value of the number that corresponds to A minus the number that corresponds to B. Remember, absolute value just means that it's the distance from 0. So first you'll do your subtraction and then find distance from 0. Essentially, it's going to make it positive. Pause here, because I know that was a lot of writing. And then we will take a look at actually finding some distances using our ruler postulate. Okay, so what I want to do is find the distance MA. Now, I know you can just look at that and see your distance from M to A. It's 1.5, because you can count. But I'm going to actually use our ruler postulate here. So the number that corresponds to M is 1/2, or 0.5, minus the number that corresponds to A is 2. When I do that subtraction, I get negative 1.5. And when I do the absolute value of that, I get 1.5. So this notation means, so this MA means the distance from M to A is 1.5, and our units here were inches. Let's do another one. Let's do AH. So again, I'm going to do the number that corresponds to A, which is 2, the number that corresponds to H, which is 5. I'm going to do that subtraction and then take the absolute value. I know you can also count, but I want to give you that formal definition. That is really all there is to our ruler postulate. Let's take a look at another postulate, and this is one that we will use a lot. We will also use it a lot in our proofs as we start doing those later on. So the one we're going to do right now is the segment addition postulate. So a segment, remember, is just a portion of a line that has two endpoints. So in this case, I'm looking at segment AC. If 3 points A, B, and C are collinear, remember that means together on a line, and B is between A and there's a typo, that should be a C. Let's correct that, please. Then AB plus BC equals AC. So we are looking at this segment from A to B, and then, the measure of that segment from A to B plus the measure of the segment from B to C is equal to the measure of the segment from A to C. In other words, the two small parts of the segment add up to the big part. That's all we're doing there. Okay, so again, there's a typo in the booklet. Let's change this, please. 3 points A, B, and C are collinear, and B is between A and C. Make that correction. Then AB plus BC equals AC. Again, notice this notation here, this AB means the distance from A to B plus the distance from B to C is equal to the distance from A to C. And that is it for those two postulates.